Good morning. So today is a better day, hopefully for you too. We are going to go over 7.2. I shared with you on Google my notes that I wrote out, and so that's what I'm going to go over with you right now. Okay, so if you want to pause it and go in here and copy these down and leaving spaces for the examples, you can do that right now and then come back and watch the video. Okay. So you will need your textbook for this. We are going over one of the tables, so you'll need your textbook. All right. So we are going to go ahead and I'm going to hide this and pull that up and go ahead and get started on that. Okay, so we have 7.2. This is the last section in chapter 7. Go ahead and read through this. A couple of things that we've gone over is point estimator. Close that. Is point estimator is the X bar, the sample mean. Confidence interval, it's written as an interval like in parentheses, or you can write it as X bar plus minus E. That's where you get those from. Sample size. Sample size is how many samples you take of the data. We are going to be able to find out what the sample size is for a particular mean given a confidence interval. And then the sample mean X bar is the best point estimate. And then recall about confidence intervals. We have all this notation that we need to remember. And the requirements are also important. So the requirements is that the sample is a simple random sample. Either or both of the conditions are satisfied. Population is normally distributed, or N is greater than 30. Okay. The format of confidence interval, I just talked about that. This is a way to find your margin of error, E, and that's going to be what you use for your confidence interval. So we are going to talk about the T distribution, or t-test is what we are doing, student t-test. So that's why that's a T instead of a Z like we've been doing. And DF means degrees of freedom. And you take N and you subtract 1 from it. We will find the critical value of T alpha over 2. It separates an area alpha over 2 in the right tail. So remember we have that. So if we're doing a 95% confidence interval, you have your lower tail and your upper tail. This is the area alpha over 2, and this is also an area alpha over 2. But together they make alpha. And remember, alpha comes from your confidence level. And we actually take 1 minus that, 1 minus your confidence level is how you get alpha. And then, so if we look at our confidence, I'd already written that down. Confidence level, there's the different confidence levels, and then here are the different alphas that go with it. Okay, so let's keep on rolling through. Here's some important information about the T distribution. We're going to do the student t-test or just t-test, and we'll see that in our calculator. So different for different sample sizes. The mean T equals 0, just like standard normal T. So whenever we do our standard normal, we have Z in the middle. And so the same thing will be here. Your T equals 0 will be in the middle. Just like normal distribution, Z equals 0. Remember, that's how far away it is from your mean. So if it's on the mean, it's 0. Has some general symmetric bell shape as a standard normal, but it reflects the greater variability that is expected with small samples. So I had a picture in my book that I wanted to show y'all. So this is on 319, but the green represents standard normal distribution, and then the blue, see how this says N equals 3? That's a small sample size. N equals 12, that's a pretty small sample size too. But the more samples that you gather, the better it's going to match the standard normal distribution. So as the sample size gets larger, the distribution gets closer to looking like a standard normal distribution. And we will use t. This is how we find t, the t value, and that's our formula. And we can use the calculator to do this, and we can also use table A3 on page 6. Let me see. 686 is the t distribution, the critical values. So see how this has degrees of freedom? So remember, degrees of freedom come from 1 minus your sample size. Or your sample size minus 1 is what I should really say. And then your area in 2 tails, your area in 1 tail, that's your alpha values. And then we can also use our calculator, and I'll show you how to do that in just a little bit. So here are the instructions for that, but we'll go over it in a little bit, but I wanted you to have it right there. Okay, so procedure for constructing a confidence interval. First thing you have to do is check your requirements, simple random sample, or maybe it's both, yes, and population is normally distributed, or n is greater than 30. With the standard deviation being known, SD is your standard deviation, usually the case. Oh, no, unknown, sorry. It says unknown. Use degrees of freedom as n minus 1 in either technology or the table to find the critical value. Then you're going to find your margin of error, and then construct your confidence interval, which is taking your sample mean and adding and subtracting the margin of error to get your sample mean. Whenever you round, you're going to round 1 more decimal place than original data, if you're using data that they've given you, or using summary stats, whatever they've given you, like x bar equals this, mu equals this, sigma equals this, the same number of decimal places as your mean, your sample mean. Okay, so let's go ahead and do our first example. So on this one, all we're doing is we are finding the critical value. So remember, this is called your critical value. Okay, so some information that we have that n equals 15, so it's important to write. We also have a 95%. 95% is our level. So something that we need to do to find our confidence is we need to use our degrees of freedom. So our degrees of freedom is 15 minus 1, which is 14. And then we need to do alpha. Alpha is, since this is 95% is 0.05. So that's in both tails. And then alpha over 2, because we need to do alpha over 2 there, is half of 0.05, which is 0.025. Okay, so now we are going to use our table to find that critical value. So whenever you look at your table, before I do that, let's talk about, we don't know what it really looks like, but we know that between there and there, this is your 95% area. So alpha over 2 are these two. So the area here is 0.025, and the area here is 0.025. So we need to find those critical values right here and right here. And so we'll do that using the table. So if you notice on the table, we have degrees of freedom. So our degrees of freedom is 14. And then it says area. So this top part, this is your alpha over 2, okay? And so this one is just alpha. So let's look at 0.025. And I'm going to go down 2.145. Oh, you can't see that, sorry. 2.145. So that's our critical value. Okay. Let's look at the data. Use the data below corresponding to birth weights of baby girls. Measure with HG, that's hectograms. Here are the summary stats. We have N equals 15. Sample mean is 30.9, and then the standard deviation is 2.9. Construct a 95% confidence interval. Okay, so first thing we want to do is check your requirements. And you know what I realized? I did not show you how to use the QQ plot in the calculator because our requirements are that it's a simple random. That's true. So A was simple random sample. Random. There we go. Yes. B is either it's a normal distribution or N is greater than or equal to 30. It's not greater than or equal to 30. So no. So we got to check standard normal. Okay. So remember how I found that? Oh, that was over here. So we need to, it's not greater than, I always write that. It should just be greater than. All right. So I'm going to show you how to do a QQ plot in your calculator. Okay. So first thing you want to do is you want to go to stat and you want to edit. So stat, edit. I don't like how I wrote that. But you want to do stat and then edit. And then you want to enter data in L1. Okay. So I've already done that. I've already put it in L1. So it's all in there, all 15. And the way you can double check, you can look at it there too. Okay. And so what we want to do is we want to then go to stat plot. So second y equals is your stat plot. Want to turn it on. So plot 1, we want it on. And then our type is the very last one. That's your QQ plot. And whenever you click that, it's going to change this whole bottom part. So it says data list L1, data axis X, and then mark it with whatever you want, color, whatever. So then you hit zoom 9 because that is your stat stuff. That's your data. You want to zoom into the data. And so look at that. Remember to be normally distributed, it must look like a line, right? Linear. So if it's going like this, then it looks good. So yes, it is. Yes, meets requirements. Okay. So now we can move on to number 2, and I'm going to go to the next page for that. Okay, number 2. So back at our notes, number 2 says, with our standard deviation unknown, but don't we have the standard deviation? Which one am I on? Okay. So what we want to do is I want to look at, we're doing 95%. So that means our alpha is 0.05 and our alpha over 2 is 0.025. So how many N do we have? How many samples do we have? We have 15. So then our degrees of freedom is 1 minus that, so it'd be 14. Okay, so then using our table, we can find our critical value. So it's just like the last one. Same exact things. So it's 2.145. because its degree of freedom is 14. We're doing 95%. So our T alpha over 2 is 2.145. Zoe is just begging to be held. She is scratching my jigger. She sleeps all day. I wonder if y'all's puppies sleep all day inside. All right. So then we want to actually do our confidence interval. So we need to do our margin of error. So that is our margin of error. So I'm going to write that down. T alpha over 2 times S over square root n. Okay, so we have that done. So now we just plug 2.145 times S was 2.9. Sorry, I can't see that. 2.9 over square root of 15. And that gets your margin of error. Second quit. 2.145 times 2.9 divided by square root 15. 1.606. Okay, so then to find your critical value, you are going to use what X bar is. Remember, X bar is 30.9. So we are going to add 6.06 and then subtract it. So I'm just going to leave that in there and do 30.9 minus that, which is 29.29. Less than our population mean, and then do 30.9 plus that, 32.51. Okay, so that's our confidence level. Okay, so now do you want to see in the calculator? Okay, so let's look back at our instructions for the calculator. There's a couple of pages back. So it's right here. So we've done it by hand. So let me show you how to do it in the calculator. So it says stats, and then let me move this up. Oh, let me go that way. There we go. Stat, and then I don't do that yet. Then go to test, and we want to go to the T interval. And I want to go ahead and use the data that I put in because I already did that. And then L1, frequency 1, sea level, that's our confidence level, 0.95, calculate. Check that out. It actually gives us our confidence level first, and then it gives us our sample mean, sample standard deviation, and then how many values of n we have. So let's double check it. 29 point, no, it's close, right? I don't know why it's not the exact same, but it's pretty close. I guess if we were to round it, it would be 29.3 and then 32.5. Oh, it's because it's using that, the data. And what we used on here was our stats. So let's go back and let's do it with the stats instead. Then we should come up with the same thing. So go back, T interval. Instead of using the data that we have, I'm going to go over to stats. And I'm going to change this because this is just 30.9. And this was 2.9. Okay, now it's the same. So why was it different? It was because for the data, I was using the actual data, not rounded data. Here, I'm rounding things. So that's why it's different. But if I use the rounded numbers, which was the 30.9 and the 2.9, then I would get this same thing that I got a minute ago. All right. The important thing about confidence intervals is not just finding them; it's being able to correctly interpret the results. So we've got to remember that the confidence level gives us the success rate of the procedure used to construct the confidence interval. The ultimate goal is to correctly interpret the results. So with this data that we have, we need to interpret it, and this is the way it should be interpreted. We are 95% confident that the interval from 29.2 Hg to 32.5 Hg actually contains the true mean. Okay, so caution. Confidence intervals can be used informally to compare different data sets, but the overlapping of confidence intervals should not be used for making formal and final conclusions about the equality of means. So when you're comparing, whenever you compare those confidence intervals should not be used to make those final conclusions. All right, the last thing is determining the sample size. So a lot of times we're given the sample size, but sometimes we're not. Actually, we want to find we want to find this particular confidence interval. What is the number of samples that we need? And so that's what this is finding. We want a certain confidence interval. So what does the mean have to be? So here's notation again. Our requirement to see how we move back to z-scores. We are going to find the z-score or use the z-score to find our sample. So requirement just needs to be a simple random sample. Formula is this. Round off, because we're talking about number of samples, we're going to round up to the next whole number. Don't ever round down, go up. All right, so here's our first, or our only example for this. How many STAT students must be randomly selected for IQ tests if we want 95% confidence that the sample mean is within 3 IQ points? Okay, so first thing we want to look at is, 95% confidence. 95% confidence. So alpha is 0.05. And then alpha over 2 is 0.025. This 3 means that you're confident, that's your margin of error. Because it says you want it within 3. And let's think back at what IQ scores are. Our IQ scores, are they normally distributed? Yes. And they're normally distributed with a mean of 100 and a standard deviation of 15. And that's something we learned a while back. But if you need to double check me on that, or if you're not quite sure, look up on the internet just IQ score, normal distribution, mean, and standard deviation. And this is what it is. Okay, so our confidence interval is going to include that error. So we need to find our z-score. Okay, our z-score is, go back to our table A2. Trying to find it. And we want, here's our common critical values down here. 0.95 is our critical value is 1.96. So that's what we use. 1.96. So then our n, we're going to use that formula. Z alpha over 2 times your standard deviation over your margin of error, all squared. So we plug that in. 1.96 times 15 over 3 squared. So we'll put that in. So, okay, 1.96 times 15 over 3 squared. 96.04. But remember, you're supposed to round up because we're talking about samples, so it's 77. Okay, that's your number of samples that you need. Okay, and then, oh, we have one more. I forgot about that. Okay, and now we are going to estimate a population mean when sigma is known. Use the same 15 birth weights from the first, and we are going to estimate population. All right, so we have our 95%, so we know that our alpha is 0.05. Alpha over 2 is 0.025. Our z alpha over 2, that's one of those critical values that we've written down several times, 1.96. And our sample mean from the data that they've given us is 30.9. And we are going to construct the confidence interval of 95%. So this is where we need to find our margin of error. So our margin of error is found by doing your z-score times alpha over n. So it'd be 1.96 times 2.9 over, square root of n, square root of 15. So when we plug those in, we get 1.467. So then to find our critical value, we do x bar plus e, plus minus e, which will be 30.9 minus 1.467 and 30.9, I just say minus and then do plus. So whenever you do that, you get 29.4, you get 32.4. So 29.4 is less than our population, true population mean, 32.4. Okay, so I know I went really fast on that, so if you need to slow it down, pause it, come back to it, you can. I'm just trying to get my video completed so it doesn't take forever to upload. All right, I believe that is all. Last thing is choosing the appropriate distribution. So you've already written these down. So you need to check these conditions before you decide, okay, the T distribution or the Z distribution. These we will not really cover. It says section 7.4, but we're not actually doing that. So the only ones you need to worry about are these, okay? All right, if you have any questions, email me. Y'all have a great day. If I can get this closed.